Everybody, and welcome to the Algebra 2 CP Unit 2 test review. So I'm just going to jump right in and we're going to get started on number 1. So we're going to start by stating the transformations and what each transformation does. So starting with this first one, we have y equals f of x plus 2. So we got to remember that when we have something in the parentheses like this, that means that our graph is going to be moving left or right. And we have to remember that our formula is y equals a times x, little thicker pen. We have to remember that y is equal to the good Lord, I'm sorry, I keep writing the absolute value. A times f of x minus h plus k. So this minus means we're going in the opposite direction of what we think. So when we have something like plus 2, we would originally think that maybe we're going to the right, but that negative means we're going to the opposite. So we're actually going to the left too. Similarly with number 2, we have x minus 3. Again, that's in the parentheses, so that's left and right. And it's the opposite of what we think. So we're actually going to be going to the right 3. Okay, and that's coming from that x minus h inside the parentheses. It's the opposite of what we think. Now, next we're going to worry about if we have f of x plus 1. So when we have that plus 1, that's the same as that plus k. It's using the same sign. So we're going to go in the same direction as what we would normally think because it's a plus. So if we had a plus 1 on the outside, outside is where we shift up and down. And it's the same as what we think. So we are, in fact, going up 1. Similarly, for number 4, we have a negative 4. And that means we're going down 4. Okay. Now we have some coefficients in front of this f of x. And so we have this 6 and this 2/3. So that's where we're talking about a. And a handles two things. A actually handles stretches and shrinks as well as reflections. So when the absolute value of a is greater than 1, okay, this is what we call a vertical stretch. And we specify by how much. So we specify by a. Now, when the absolute value, so that means the positive value, just the number, not the sign in front, is less than 1. So when we have something like 1/2 or 1/3 or 2/5 or something like that, we call that a vertical compression. We can also call it a shrink. Both of those would be accepted, vertical compression or shrink. I like using compression because it separates stretch and shrink in my brain. And again, that will be by a. So for number 5, a in this case is 6. 6 is greater than 1. So we would say this is a vertical stretch by 6. Now, when we look at question number 6, we have 2/3. Well, 2/3 is actually less than 1, right? It's between 0 and 1. So 2/3 means that this is in fact a vertical compression. Also known as a shrink. So you don't have to write compression / shrink. You can write compression or shrink. And we would say by 2/3. Again, we want to specify how much we're stretching or shrinking by. That is very important. Now, the only other thing that this a out front does is it tells us whether we are reflecting or not. Okay, so I need to change colors. So if this a right here, if we have a positive a, oh, I don't want you to think that arrow is going there. Okay, so if we have a positive a, that means nothing changes. Okay, so if we have a positive a, there is no transformation being applied to this. However, if we have a negative a, that means we are performing a reflection over specifically the x-axis. Okay, again, just like we had to specify that it was a vertical, so we had to specify vertical in the last two, and we had to specify by what number. In this one, we have to specify what axis we're going over. And we also want to call it a reflection. We don't call this a flip. A flip is what a gymnast does. This is a reflection. We are reflecting it kind of like a mirror in mathematics. So we would call this a reflection. And we don't really have to specify vertical or horizontal because we're specifying using that x-axis. So this is a reflection over the x-axis, and that is due to the fact that there is a negative out front. So please note that the negative and the number are two different things. For this next one, I'm going to be using this graph to perform these transformations, but I have some graph paper over here, so this is where I'm going to draw them. So we have 9 through, I think, 13. I'll just change my numbers real quick. 9, 10, 11, 12, and 13. Okay, so starting with this first one, when we do our transformations, we do them from left to right. So when I have this negative out front, that should be the first thing we see. And what that negative means is, like we just said, whenever we have a negative out front, that's changing our graph. It's causing a reflection over the x-axis. Okay. So I am going to go over to these graphs, and I'm actually just going to focus on that one first. So I'm going to draw my original graph just so I can rewrite it. So it went through -4, +3, 5, 3, and 6, -1. Okay, so this is my original graph. Okay, so I'll draw my original in blue. And the first transformation I'm going to perform is a reflection across the x-axis. So this isn't my final graph, and if you want to go ahead and do both transformations at the same time, you're more than welcome to. Just for the sake of reviewing, I'm going to show them one at a time. And I'm going to draw my original actually as a dotted line so that I know it's not my final. Okay, so all of these points here, I'm going to start by doing a reflection across the x-axis. So all of these points, their y values are going to go to the opposite side. So -4 is 0. We're going to change that y value, but 0 reflected is just 0, so that'll actually stay the same. 0.3 will be reflected across that x-axis, and the y value will go negative to become 0, -3. 5, 3, again, will be reflected. The y value will go negative, so it'll become 5, -3. And 6, -1, again, that y value is going to be reflected, so it'll become a 6, +1. Okay, I'm going to continue using a dotted line here just because I'm not done yet. And I'm going to see what other transformations I have. So my next transformation, which looks like the last one, we have it in the parentheses. So that means we're going left or right. And we need to remember from the very beginning that when it's in the parentheses, it's the opposite of what we think. So this is a horizontal shift, and we're going to the left one, right? It's positive, so we would initially think we're going to the right one, but in fact, we're actually going to the left one, because it's the opposite of what we think. So I'm going to take that graph that I just reflected, and I'm going to move all of those points to the left one. And so this red graph that I have here, this will be my final graph for this first problem. Of course, I would hope your lines are straighter, so try to use a straight edge to help you out. But that is essentially what the graph should look like. So we reflected and went over the x-axis. Those are the only two transformations. So we are going to be good from there. Okay, moving on to number 10. So again, I'm just going to go over here and I'll draw the original. I'm just transferring it so you can see where I'm getting some of these points from. And again, I'm going to draw it as a dotted line just because I'm not done yet. Okay. So this next one, I'm actually going to perform the horizontal and the vertical transformation together. So from left to right, we don't have anything in front. Inside the parentheses, however, we have a x minus 1. Again, when it's inside the parentheses, that's the opposite of what we think. So we're actually going to be moving to the right one. And that plus 3 on the outside, that is a shift up or down. And it's the same as what we think. So we're actually going to be shifting up. I'm sorry, it's the same as what we think. I believe I said that, up 3. So we'll take everything on this graph that we just had, and all we need to do is move it to the right one and up 3. Move to the right one and up 3. Oh, I'm sorry. I moved up 4 by accident. Right one up 3. And right one and up 3. So our final graph for this one, because those are the only transformations we have, would look like this. Okay. Moving on to the next one. Again, I'm going to draw that original function just so I have a reference point. And we'll start listing our transformations. So again, we're going to move left to right. The first thing we should see is this this positive 1/3. So that 1/3 is less than 1. That means that this is a vertical compression or shrink. By 1/3. Okay. So one thing I want us to remember is that when we go ahead and multiply y values by 1/3, that is the same as if we decided to divide by 3. So that's really the same thing. So what we're going to do for this vertical compression is we'll take all of just the y values. We're not going to touch the x values, right? Because this is vertical. Vertical means y values. And we're going to multiply them by 1/3, which again is the same as dividing by 3. So for 0, the y value is 0. 0 times 1/3 would be 0. So that's actually going to stay the same. 0, 3, we'll take that y value of 3 and we'll multiply it by 1/3. Or if it helps, you can think of it as dividing by 3. And 3 divided by 3 is going to give us 1. 5, 3, again, we'll take that y value of 3 and we'll multiply it by 1/3 to get 5, 1. And then 6, negative 1, well, negative 1 divided by 3 or times 1/3 is going to be a negative 1/3. So it's not going to be a perfect point, but it'll be somewhere right about there. And so this graph will look like this. It should look squished because it's a compression. And in fact, it does. Okay. But we're not quite done yet. Sorry, I should have done that as a dotted line. That's my B. We still have to do any other transformations that are attached to this. So we have this minus 4 that is happening right here. That is on the outside of the parentheses, so that means we're moving up or down. And in this case, because it's negative, it means we're moving down 4. Okay, so we're going to take all of these green values and we're just going to shift them down 4. The first point will go there. Second point will go here. Third point will go here. And the fourth point is going to be kind of hard to see, but it'll be right about here. And then we connect our dots. I'm sorry, our points. So that is what our final graph should look like. Okay, moving on to number 12. Again, I'm going to draw the original. Okay, then we'll look at our transformations. So again, we're going left to right. The first thing we should see on the left side is this negative. So again, this negative is going to mean a reflection, because that's what a negative means, negative on the outside, a reflection over the x-axis. So I'm going to start by just doing that. So I'll take this graph that I got and I'll reflect it. So again, negative 4, 0 reflected is still negative 4, 0. 0, 3 will flip the sign of the y value, so it'll be 0, negative 3. 5, 3, again, we'll flip the sign of the y value to get 5, negative 3. And 6, negative 1 will flip that sign of the y value to get 6, positive 1. And so this is what that transformation will look like. And then we got to see if we have any other transformations. We do. We have one more. We should see it's right here in the parentheses. It's x minus 2. So when it's in parentheses, remember we go left or right. Because it's minus, we would maybe initially think that we had to go to the left. But remember, because of that equation, we're going the opposite direction of what we think. So we'd actually be shifting to the right 2. So we'll take all of those points we just got and we'll shift them to the right 2. And so our final graph will look something like this. Okay. And the last one, this is probably the most complicated one, but we're just going to go one piece at a time and get to the end. So again, I'm going to draw the original function. Okay. So the very first thing I should notice is the negative, okay? I am not keeping that negative attached to 2 for my transformations because those two numbers are telling me two different things. So I'm going to focus first because the first thing I see on the left side is the negative. Like we just said, that is a reflection over the x-axis. Okay, so I'm going to take all of those points that I just got and I'm going to reflect them. So again, negative 4, 0 will be the same. 0, 3 will become 0, negative 3. 5, 3 will become 5, negative 3. And 6, negative 1 will become 6, positive 1. Again, this is the same reflection that we just did. It's where I'm flipping the signs of the y values. And so that would be our first transformation. Okay, so we've done the first one. Now that we've done the first one, now we can worry about that 2 that's also in front of the f of x. So that 2, that is saying a vertical, because it's greater than 1, that's going to be a vertical stretch by 2. Okay. And remember, whenever we have a vertical compression or a vertical stretch, we'll multiply the y values by whatever that number is. So we're going to go ahead and we're going to multiply all of the y values by 2. So from the green graph, negative 4, 0, we're not going to change that x value. We're just going to change the y. So 0 times 2 is still 0, so that one's not moving. 0, negative 3. Well, negative 3 times 2 is a negative 6. So that will turn into 0, negative 6. Again, we're multiplying the y values by 2. 5, negative 3. Again, that negative 3 will multiply by 2 to become negative 6. And 6, 1, that 1 will be multiplied by 2 to get 6, 2. So this is that vertical stretch. And it should look stretched. It should look a little pulled apart. Okay, so what I did there again was I multiplied all the y values by that coefficient of 2. Now I can worry about whether I'm moving left, right, up, or down. And I'm going to do those together. So again, inside the parentheses is telling me that I'm going the opposite direction of what I think. So that x plus 2 is telling me I'm actually moving to the left 2. And then that -1 on the outside, that's telling me vertically whether I'm going up or down, and it's the same as what we think. So I'm actually moving down 1. So I'm going to take all those points from that purple graph and I'm going to move them left 2 and down 1. So left 2, down 1, left 2, down 1, left 2 and down 1, and left 2, down 1. Again, any of these, I am okay with you doing multiple transformations in one fell swoop. So like if you want to reflect and vertically stretch at the same time, that's okay. If you want to move left and down at the same time, that's okay. If you think you could do them all in one go around, I'm okay with that. Just know that the more work you show, the easier it is to figure out where you may have gone wrong if you do mess up. But it's not a requirement. So if you feel really confident, you can go ahead and just plot that final graph. If not, I would go ahead and show all of the steps you took to get there. Okay, so now we're going to do something similar, and we're going to do it with absolute value this time. So instead of just having some random f of x that we were given, we're going to work with the absolute value. So we should hopefully remember that the equation for the absolute value is y equals a times the absolute value of x minus h plus k. Okay, so this is the formula. This is very, very similar to the formula we just used. All we did was replace f of x with those absolute value bars. So we'll perform very similar transformations. However, there are some things that we can get right off the bat. The first thing we can get is what's called the vertex. So the vertex is where our graph changes, where it creates that V shape, and that will always happen at h comma k. Similarly, the other thing we can get is the is what's called the axis of symmetry, or sometimes a line of symmetry, and that will always be x equals whatever h is. So the x value of our vertex will give us what our x equals needs to be for our axis of symmetry. So starting with this first one, we should notice we don't have any numbers added to the inside of this x. So that's like saying x minus 0. So our x value of our vertex is 0. And remember, it is hk. So h was 0, k is this number on the outside, so it'd be 0, -4. Okay, so we're going to use that to check as we graph. So each teacher does it a little bit differently, but this is how I'm going to go through it. We're going to start by plotting the parent function. So we should hopefully remember that the parent function is a v with vertex at 0, 0. These are the main 3 points that you would need to graph the parent function. And then from here, you can create that V shape. Oh, I wanted to do this as a dotted line. Okay, I'm probably not going to do this next. So this is our parent function. Okay, it goes through 0, 0, 1, 1, and -1, 1. It is the absolute value graph. Now what we want to do is essentially what we just did when we were transforming those other equations, and we're going to do transformations of this absolute value graph. We're going to treat this like our parent function, where we started in the last one. So moving left to right, we're going to identify the transformations. So the first thing on the left we should see is this 2. Okay, so that 2 out front, right, that's greater than 1. So that means that one of our transformations is a vertical stretch by 2. So I'm going to go ahead and I'm going to do that first. So vertical stretch by 2. That means I'm going to take the y values and I'm going to multiply them by 2. So 0 times 2 will still be 0. So that vertex is staying the same so far. 1, 1. I'm going to take that y value of 1 and multiply it by 2 to get 1, 2. negative 1, 1. Again, I'll multiply that y value of 1 by 2 to get negative 1, 2. So this will be our first transformation that's happened here. And it'll look like this. Okay. Now, you can also think of this as that 2 is the slope, right? From the vertex on the right side, it's the slope of the right side. We went up 2 and to the right 1. Okay. It's at this point that we probably want to double check whether we're opening up or down. Remember, we open up when our number is positive, and we open down when our coefficient is negative. In this case, our coefficient is positive, so we're on the right track. Now we got to look at our other transformation. So again, we don't have anything in that absolute value bars, but we do have this negative 4 on the outside. That means that we're going to be shifting up or down, and it's the same as what we think, so we're moving down 4. So I'm going to take all of those y values, and I'm going to move them down 4. So my vertex will shift down 1, 2, 3, 4. So once I shift that down, I want to double check that it matches the vertex of what I said at the very beginning, which it does, 0, negative 4. Okay, so we're on the right track. So then I can shift all of my points that I have down 4. Okay. Once I get that, 3 points is all I need to be able to connect my points and create my graph. Okay, so this will be the left side. And those will be the right side. Okay. So this red graph is what your final graph should look like. Your domain, especially for an absolute value, is always going to be negative infinity to infinity, right? Domain is left to right. Range is bottom to top. So the lowest value that this hits is right here. The lowest y value is a negative 4. And it's going all the way up as far as it could possibly go. So it's going to infinity. Typically, our range starts at from 0 to infinity. But when we move our graph down 4, our range will have to shift down 4 with the graph. So that's why this is starting at a negative 4 and it's going to infinity. Okay. Moving on to the next equation. Okay, so we have y equals negative 1/3 absolute value of x plus 2. So let's start by identifying h and k and getting our vertex. So remember, h is inside the parentheses, but as always, it's the opposite of what we think. So it should actually be at negative 2. But we don't really have a k added on the end, so that's like saying plus 0. So our vertex should be negative 2, 0. Okay. If I did ask you to write the axis of symmetry for these, again, and I'm going to write this off to the side, the axis of symmetry or the line of symmetry is the vertical line going through your vertex. So it'd be x equals 0 in this case. And in this one, again, it's matching that x value of our vertex. So it'd be x equals 2. I'm sorry, negative 2. For our axis of symmetry or line of symmetry, either one. Okay, let's get to transforming. So the first thing we should see from left to right is the negative. Again, remember the negative and the 1/3, we're going to kind of separate from one another. So the negative is saying that this is a reflection over the x-axis. So I'm going to go ahead and I'm going to plot my parent function like I just did on the last problem. This is the absolute value parent function. That's where this is coming from. Okay, and then because my first transformation is a reflection across the x-axis, I'm going to reflect these 3 points. So 0, 0 reflected will stay the same. Negative 1, 1 will become negative 1, negative 1. And 1, 1 will become 1, negative 1, right? I'm flipping the sign of my y values. Okay, and that is my first transformation. Then we should hopefully move to the next one. So the next one we should see is this 1/3. So we need to remember that 1/3 is less than 1. So that means that this is a vertical compression by 1/3. So we can take the y values and we can multiply them by 1/3. We could also consider dividing them by 3 because that's the same thing. Or we can also use this as a slope of our both sides. So going down 1 and to the right 3. Because we still want to open down. We still want to have that reflection. Okay, but you can also think of this as we just took the point 3, negative 3, and negative 3, negative 3. So those are points on our graph. And we're keeping the x value the same, multiplying that y value of negative 3 by 1/3. So negative 3 times 1/3 is a negative 1. And negative 3 times 1/3 is a negative 1. And again, 0 times 1/3 is still 0. So that is our vertical compression. So whether you want to think about that as a slope, saying that it's 1/3, and it's opening down, so it should be down 1 to the right 3, that's fine. But you can also think of it as taking those y values and multiplying them by 1/3. Technically speaking, you could have taken 1, negative 1 and multiplied that y value by 1/3. But negative 1 times 1/3 is a negative 1/3. So it's like right here, which is kind of disgusting. But that's totally up to you. I would also accept this. So it looks something like that. Okay, and that would be our vertical compression. Or shrink, depending on your preferred word. Okay, then the last thing we have to do is this +2 right here. And that +2 is on the inside. So remember that's going the opposite of what we think. So that means we're actually shifting to the left too. So I'll take all of those purple points and I'm going to shift them to the left too. Starting with my vertex. Okay, and I double check that that matches the vertex I wrote earlier, which it does. So now I can shift all of these points to the left too. And I know this looks messy. Again, you can do as many of these together or not as you would like. But once we get that, we can connect our points. And we can get a pretty decent looking graph, which would look like this, the red one. Okay, so again, our domain is going to be all real numbers, otherwise known as -infinity to infinity. And our range is bottom to top. So when we reflected our graph, we also reflected the range. So the range is actually going from -infinity, because these arrows keep going down, and it's stopping at the top y value of 0. And it's containing that value. So we use a bracket. Again, axis of symmetry is that vertical dotted line right here that's going through the value of -2. You don't have to plot the axis of symmetry, but if I asked you, I want you to make sure you know what it is. Okay, number 16. So again, we're going to go left to right, and we're going to start, well, we'll start by identifying our vertex. So again, vertex is HK. So opposite of what's on the inside, which is 4. Same as what's on the outside, which is 2. And we'll double check that one later after we've done all our transformations. We'll start with the parent function, as always. And we'll move left to right. So first thing we should see is the negative. Remember, the negative and the 1/2 are separate from one another. So that is a reflection over the x-axis. That's what that negative means. So we're going to take these points, we'll reflect. And so this will be our first transformation. Hopefully we're good so far. From there, we should see this 1/2. So this 1/2, again, is a vertical compression or shrink because it's less than 1. So it's a vertical compression by 1/2. So again, we can think of that as a slope going down 1 and to the right 2. We can also think of it as taking this point to -2 and multiplying those y values by 1/2. So -2 times 1/2 would give us 2, -1. And this point 2, -2 would also give us -2, -1. So again, you can think of this as the slope, or you can think of it as taking that y value and multiplying it by 1/2. Whatever helps you. And so this would be our next transformation. And then we're going to look at the last ones. So that -4 on the inside, that means we're going the opposite of what we think. So we're going to the right 4. And that +2 on the outside means we're going up 2 because it's the same as what we think. So we'll take all of our graphs to the to the right 4, or we'll take that purple graph to the right 4 and up 2. Now we want to double check that that matches our vertex that we wrote at the beginning, which it does. So now we can move all of those purple points to the right 4 and up 2. And then we have 3 points, which is enough to get our graph. And we can just continue those lines with our straight edge. So again, I do want to mention the axis of symmetry is going to be x equals the x value of our vertex, which is 4, right? That's a vertical line. It's where we can fold our graph over on itself. Again, our domain is always -infinity to infinity. And our range, again, our graph was reflected and shifted up 4. So our range will also reflect and shift up 4. So it's bottom to top. So it would be -infinity because these arrows keep going down to, oh, I'm sorry, not 4, but rather 2 because we shifted up 2. Okay, to 2. Because our graph shifted up 2, so our range has to also shift up 2. And those red graphs should be our final graphs. So now we are going to write the equation of a graph. So the first thing we're going to need to identify is the vertex. So that would probably help us the most as we want to go into our equation. So maybe the starting point for that should be figuring out what our line of symmetry is. So our line of symmetry is happening through here, right? It's this vertical line, and we write vertical lines as x equals, and that x value is -5. So x equals -5 is going to be our, so I'm going to put a little thing for vertex down here, just so that we know. It will also be the x value of our vertex. Okay, our vertex is occurring right here, and that is at -5, -2. And so that'll be our vertex. So again, line of symmetry always has to be an x equals. It's a vertical line, and it's the x value of our vertex. Okay, we should hopefully see that this graph hasn't really been stretched or compressed or reflected. It has a slope of 1, right? We're going up 1 to the right 1, up 1 to the right 1, all the way clear across our graph. Okay, so it has a slope of 1, so it hasn't been stretched or compressed. It's just been shifted to the left 5 and down 2. So if we have an equation where, again, we're doing the absolute value, so a times x minus h plus k, once we find our vertex, it should be pretty simple. So it hasn't been reflected and it hasn't been stretched or shrunk, so that a is going to stay the same. So we'd say y equals x minus h, so minus a negative 5. So that would actually turn into a plus 5 plus k, which is a minus 2. So that would be our new equation, right? Because we shifted to the left 5 and down 2, but we didn't stretch or shrink or reflect. Our domain is going to be negative infinity to infinity. And our range, which is from bottom to top, will be from negative 2, because that is our lowest possible y value. And it's going all the way on to infinity. The last thing is the x and the y intercepts. And we want to write these as coordinate points. So we should hopefully see our x-intercepts are where our graph intersects the x-axis, which are happening at negative 7, 0 and negative 3, 0. And our y-intercept is occurring where our graph intersects our y-axis, which is happening at 0, positive 3. Okay, so we want to make sure we're writing those as coordinate points. Okay, moving on to the next problem. So the first thing we should be able to identify is that line of symmetry, otherwise known as the axis of symmetry. Remember, it's always an x equals, and it's happening where x is equal to a positive 1 this time. Now we want to identify our vertex. So our vertex is where our graph changes slope, which is happening right here. And that's at a positive 1, negative 2. Okay. Our graph still has a slope of 1, up 1 to the right 1, clear across. So it hasn't been stretched or compressed. And it's still opening up, so that means that A, that leading term, is positive. So the only thing that's really changing is how it's moving. It's a parent function graph that's been shifted to the right 1 and down 2. So we'd write that as y equals the absolute value of x minus h, which in this case is 1, plus k, which in this case is a negative 2. And again, because it hasn't been stretched, compressed, or reflected, that would be our final equation. Okay. Our domain, as always, is negative infinity to infinity for these absolute value graphs. Our range is bottom to top, so the lowest possible y value is a negative 2. And we use a bracket, and then it is going all the way as high as it could possibly go onto infinity. Finally, we'll do our x-intercepts, which we have 1 here and 1 here, because that's where our graph is crossing the x-axis. So that's happening at negative 1, 0 and 3, 0. And then we'll do our y-intercept, which is crossing right here, and that's happening at 0, negative 1. Okay. And finally, number 19. So number 19 is maybe a little bit trickier, but let's start with the line of symmetry. So we have it right here. Again, it's where we can fold our graph over on itself. So that's going to be x equals negative 2. Okay, and we can also identify our vertex. So our vertex is happening right here, and that is negative 2, comma 2. So that means we know in our equation, we're going to have x minus h, so minus a negative 2, which is plus 2, plus k, so there'll also be a plus 2 on the outside. Now we just need to figure out what a is. So we should hopefully notice that this graph, unlike the others, is opening down. So because this graph is opening down, that means we've done a reflection across our x-axis, so we should have a negative out front. We should also notice that this graph, unlike the others, has a different slope. It's a lot skinnier, so it's been vertically stretched. And our slope is down 1, 2, 3, 4, and to the right 1. So our slope rise over run is 4. So we've been reflected and vertically stretched by 4. And it makes sense that it's vertically stretched because it looks like it's been pulled apart vertically. So that would be our equation for this graph. Again, domain as always is negative infinity to infinity. And our range is bottom to top. So our lowest possible y value is negative infinity, and our highest possible y value is 2. And we'll put a bracket around that because it's a closed circle. Okay, now we can move on to solving some equations and inequalities. So we want to solve the following equations and inequalities, graph the solutions, and write our answers in interval notation. So starting with number 20, we should hopefully notice that we have this 4 out front. So before we can do anything with that absolute value, we have to get it alone. So the same way we would solve for a variable, we're going to just solve for the absolute value. So to get rid of this 4 out front, which is attached by multiplication, we're going to divide both sides by 4. So when we do that, we're going to get 5x minus 4 in those absolute values, because this 4 on the outside and this 4 in the denominator will cancel. So it's important that you know that only if you have, you can only divide outside with outside and inside with inside. So we can't divide this 5x and this negative 4 by 4 because it's protected by those absolute value bars. It's inside those. We can only divide by 4, and the reason we divide by 4 is to get rid of the coefficient of 4 out front. So we'll get 5x minus 4 equals 16 divided by 4, which is 4. Okay, now we have our absolute value alone, and we can go ahead and get started solving. So we have this minus 4 here, which if we remember back to our transformations, we're actually shifting to the right 4, right? Because it's the opposite of what we think. So we're moving to the right 4, and that is where we'll start. From there, we'll use this 4 to see what distance we need to go. So this 4 means we need to go 4 in the positive direction, which would give us 8. And it also means we need to go 4 in the negative direction, which 4 minus 4 is 0. Okay. So what this is saying is that 5x is equal to all of these values of 0 and 8. But we want to find just x. So because we have that 5 in the brackets, it's at this point that we have to divide everything by 5. Okay, so you can rewrite a number line if you'd like to. I actually might to save myself some energy. So divide by 5, divide by 5, divide by 5. So 0 divided by 5 is just, this is a tiny number line. And 0, I'm sorry, I'm doing a lot. 4, 8, 0. We'll divide them all by 5. And I'm going to draw a new number line. Okay, so we should get that 0 divided by 5 is just 0. 4 divided by 5 we can just leave as 4/5. And 8 divided by 5 doesn't divide nicely, so we can also leave that as 8/5. Now, if we wanted to graph this, because this is an equation and not an inequality, our answers are that x equals 0 and x equals 8/5. So those endpoints. If we really wanted to graph that, we would do closed circles at 0 and 8/5. And that's it. We wouldn't draw any arrows or anything because this isn't an inequality. It's an equation. But that's how a graph like that would look. Okay, moving on to number 21. So again, like the previous problem, we have a coefficient out front of our absolute value. So we got to get that absolute value alone before we can do anything. So to do that, I'm going to divide both sides by a -2. Okay, so when I do that, I'll divide outside with outside. So -2 divided by -2 will cancel, leaving me with an absolute value of 3x minus 7. And 12 divided by negative 2 is a negative 6. Okay, now we got to stop and think for a second because we have this set equal to a negative number here. And we should know that by definition, absolute value is always positive. So if absolute value is always positive, there is no way that it could be equal to a negative 6. There's no way. So because of that, the answer to this is no solution. Okay, moving on to number 21. We don't have anything out front of our absolute value, so we can go ahead and start solving. We do have that 1/2 we'll have to worry about towards the end, but we're going to start the same way we normally would. So this plus 5 here, that means we're shifting, remember, opposite of what we think. We're actually shifting to the left 5. So I'm just going to draw 2 number lines. So we're going to start at a negative 5. And this 3 means we're going to the right 3, which would give us a negative 2. And we're going a distance of 3 to the left, which would give us negative 8. Now we have to, once we do that, now we can worry about this 1/2. So in order to get rid of a 1/2 x, if I just want to get x alone, I'm going to need to multiply by 2. So I'm going to take all of these values and I'm going to multiply them by 2. So that's going to give me 2 times negative 8 is negative 16. 2 times negative 5 is negative 10. And 2 times negative 2 is a negative 4. My answers are going to be those endpoint values. So x equals negative 16 and negative 4. And again, if I wanted to graph this, we'd just do closed circles at negative 16 and negative 4 and nothing else. Okay. Now let's move on to some inequalities. So looking at these inequalities, we're going to solve them essentially the same way we just did the last ones. So like the previous problems, I have this 3 out front. I have a number out front of that inequality symbol, or I'm sorry, absolute value symbol, and I got to get this alone before I can do anything. So I'm going to go ahead and divide both sides by a positive 3. So again, we'll divide outside with outside. So this 3 and this 3 will cancel, leaving us with 2x, I'm sorry, not 3, 2x minus 1. Okay, and because we're dividing by a positive 3, our inequality sign is not flipping, so it'll stay the same. If we had divided by a negative 3, at that point it would flip, but because it's positive, we'll leave it alone. And then 21 divided by 3 is 7. Okay, now we can graph the same way we normally would. So this plus 1 means we're shifting to the right 1 because it's the opposite of what we think. So we'll start at 1. And this 7 means we're going 7 in the positive direction. So 1 plus 7 is 8. We're also going to have to go 7 in the negative direction to get negative 6, because 1 minus 7 is negative 6. Okay, before we can draw our graph and all that, we have to look and we see that we still have this 2 here, this 2 in front of this x. So to get rid of that, we have to divide by 2. So that means we're going to divide all 3 of these by 2. So I'm going to draw a new number line. So negative 6 divided by 2 is a negative 3. 1 divided by 2, we'll just write that as 1/2. And 8 divided by 2 is 4. Okay, my inequality symbol is strictly less than, right? It's strictly less than. We see that right here and right here. So that means I'm going to have open circles at those endpoints of 3 and 4 because it's not equal to. And then I'm looking for something less than. That means it's an and. It also means I'm looking for something really small. So a distance that is less than this far apart, which means I'm going to be drawing in between these two numbers. Okay, I'm looking for something tiny, something less than. And so the interval notation of this would be from negative 3 to 4, right? Because I'm looking at those numbers in between them. And because they're open circles, it's going to be parentheses. So this would be my answer. Okay, looking at number 24, our absolute value is already alone, which is really nice. So we can go ahead and start graphing it. So this -9, again, opposite of what we think, it means we're actually going to the right 9. So I'll be starting at a +9 on my number line. From there, I'll be going 21 units to the right. So 9 plus 21 is 30. And I'll be going 21 units to the left. And 9 minus 21 is 12. Negative 12. Sorry. Okay. So from here, then we still have to double check, do we have a coefficient in front of that x? We do. We have this 4 right here. So we're going to have to divide by 4 in order to get rid of it. So we'll divide all 3 of these by 4, and we'll go from there. So -12 divided by 4 is a -3. 9 divided by 4, you can either write it as a decimal, or you can write it as a fraction. It doesn't really matter. I'll accept either. So if you want to write it as a fraction, you can leave it as 9/4. If you want to write it as a decimal, you can write it as 2.25. It really doesn't matter. I'm okay with either one. And then 30 divided by 4, again, you can either write that as as a decimal, which would be 7.5. Or you can write it as a fraction, which would be 15/2. Either one of those is fine. I'll accept both, so don't worry too much about it. And then we'll graph it. So in this case, we have a less than or equal to. So because it is or equal to, we're going to have closed circles at those endpoints. But again, it is less than, so we're looking for something small, something a shorter distance away. So we're going to be drawing in between again. And so you can either say -3, 7.5, I'm sorry, brackets, right? Because -3 to 7.5 with brackets, because those are closed circles. Or you could also write bracket -3, I'm sorry, I don't want that to confuse you, to 15/2. So again, both of these would be accepted. Both of these are correct. Okay, moving on to 25. So again, we don't have a number out front, so we can go ahead. We have our absolute value bars alone. We can start solving. So we're going to start here. Remember, opposite of what we think. So this is actually going to the left 7, which means we're actually starting at a -7. Then we'll use this value and we'll go 3 to the right. So -7 plus 3, which is -4. And 3 to the left. So -7 minus 3, which is a -10. From there, we should hopefully again remember that we have this coefficient of 2 here. So to get rid of it, we'll have to divide by 2. So we'll divide every single piece by 2. So -10 divided by 2 is a -5. -7 divided by 2, you can either leave it or you can rewrite it as -3.5. Either one is fine. I'm just going to leave it for right now. And then -4 divided by 2 is a -2. Okay. Our inequality symbol is strictly greater than, which means I'm going to have open circles at those endpoints. And it's greater than, so we're looking for something bigger. So that means we're going in opposite directions, and this is an or inequality. So the way we would write this, it's going to have to be a union because we have 2 graphs occurring, right? 2 different arrows. So we have -infinity on the left side going to -5. Because it's an open circle, that's going to be a parenthesis. Sorry, that doesn't look a whole lot like a parenthesis. And then we're unioning that with parenthesis -2 to infinity. And so this would be our answer. And then we can start getting into the solving and review problems from the previous unit. Guys, so I'm super nice and I decided to make a video going through the Unit 1 test review so you can get a little bit of help as you go through this and start to figure it out. So we're just going to jump right in. So starting with number 1, this is asking us to solve each equation. So when we're solving equations, our goal is to get variables on one side and constants on the other. So we don't have anything to distribute here, so I'm just going to start by, I'm going to make my pen a little smaller. And I'm going to add this 12x to both sides because that's going to get rid of it on the right side and move it to the left. So 3x plus 12x is going to give me 15x minus 17 equals 28. I will add 17 to both sides to get that 15x equals, what is that, 45? And then I'll divide both sides by the number in front of x, which is 15, to get that x equals 3. And so that will be my answer. So I got my constants on one side, which was on the right, my variables on another, and then I got rid of the number attached to x. So moving on to number 2. When we have parentheses like this, what we actually have to do first is distribute. So we should be multiplying 4 times 3s to get 12s first. And we also need to multiply 4 times negative 5 to get minus 20. Okay, so we distributed on the left. Now we got to do it to the right. So negative 2 times 8. And note that we're distributing the entire negative 2, not just the 2. We got to include that negative. Negative 2 times 8 is a negative 16. And then we also do negative 2 times negative s. Negative times a negative is a positive 2s. And we'll just bring down that negative 6s because it's not in parentheses, so we are not going to be distributing that. From there, we need to combine our like terms. On the left side, I don't have anything to combine, but on the right side, I can combine this positive 2s and this negative 6s, and that will give me a negative 4s. Okay, because I want to keep things positive and my 12s is positive, but my 4s is negative, I'm going to add 4s to both sides. So that will give me 16s minus 20 equals negative 16. Okay, then we got to get our constants on the other side. So we'll add 20 to both sides to get that 16s equals 4. And we'll divide both sides by the number in front of s, which is 16. So while we will get that s is equal to 4 over 16, this fraction actually reduces down because 4 divides nicely by 4, and so does 16. And so when you divide both of those by 4, you'll get that s is actually 1/4. So s equals 1/4 is our answer. Remember, that is reducing a fraction. Okay. And number 3 is a little tricky. So we see that we have some denominators here, which are kind of gross. So we'll start on the left side and we'll go left to right. So if I want to get rid of a divide by 5, hopefully we should know that means I need to multiply that by 5, right? A dividing by 5 and a multiplying by 5 will cancel out. And so when I do that, I need to do that to every single piece, okay? So p over 5 times 5 will cancel this divide by 5 and this multiply by 5 and leave us with just a nice p there. This divide by 4 and this 5 don't cancel, so I'm just going to put that 5 in the numerator and leave the fraction there. Okay, and then this negative 18 times 5 is going to give us a negative 90. And I got rid of that first fraction, so that's great. But now I need to get rid of the second one. So I got to get rid of this divide by 4. And the way I do that, again, is I need to multiply it by 4, because a divide by 4 and a multiply by 4 will cancel. And what I do to one piece, I have to do to everything. So p times 4 will give me 4p. This divide by 4 and this multiply by 4 will cancel, leaving me with 5p. And this negative 90 times 4 will give me a negative 360. From here, we got rid of all those gross fractions and we can solve like we did in the previous problems. So I can start by, I don't have any distribution to do, so I can combine my like terms. So this 4p and this positive 5p will combine to be 9p. And then I'll just divide both sides by 9 in order to get my solution. So negative 360 divided by 9 will give us a negative 40. And so that will be our answer. Okay, I accidentally missed these questions, so I'm going to go through them real quick. So here we are, and it says graph the following equations. So what we're going to do is we need to figure out kind of what form it's graphed in and what's going to be the easiest way to graph these. So this first one is in y equals mx plus b form. Okay, so we need to be able to pick out the m, which is the slope, and the b, which is the y-intercept. So in this case, our slope is negative 2/3, because that's the coefficient in front of x. And our intercept is this positive 4. We always want to write our intercept as a coordinate point. So it's going to be 0, 4. Okay, so when we're graphing this, we plot 0, 4. And that's going to be our first point. From there, we use that slope, so that negative 2/3. So remember, slope is rise over run. So this negative 2 in the numerator tells me that I'm going down 2, and this positive 3 means I'm going to the right 3. So I can go down 2 and to the right 3, plot another point there, and that'll be enough for my line. But I also want to mention that if we flip both of these arrows, we could also go up and to the left, and we would get the same line. So up 2 and to the left 3, and our line would still continue on with the same slope. So from here, we're just going to connect our dots, and our equation is done. Okay. Number 5 is a little bit different. So hopefully we should notice that number 5 is not in slope-intercept form. This is actually what we call standard form. It's ax plus by equals c. Okay, and so the easiest way to solve something that's in standard form is by finding the x and the y-intercepts. So when we want to find the x-intercept, what we do is set y equal to 0. Hopefully we should know this because an x-intercept is where our graph intersects this horizontal axis. And at that point, at that horizontal axis, y is equal to 0. Similarly, if we wanted to find the y-intercept, we would plug in x equals 0. Y-intercepts occur at this vertical line, which has the equation x equals 0. So we're going to start by plugging in y equals 0 to this equation to find our x-intercept. So we'll do 3x minus 5 times 0 equals 15. Okay, so that 5 times 0 is going to disappear. So negative 5 times 0 would just become 0. And anything added to 0 would just be the original problem itself. So this would be 3x equals 15, right? Because again, that negative 5 times 0 would just become 0. And adding that to 3x would just keep us with 3x. So then we solve for x. So we'll divide both sides by 3 to get that x equals 5. Okay, so we got that our x value was 5 and that our y value was 0, because that's what we plugged in. And so that will be our x-intercept. And we plot 5, 0, which is right here. Again, we want to write that as a coordinate point. So now we need to find our y-intercept. And again, we get this by plugging in x equals 0. So we'll do 3 times 0, again, into this equation, minus 5y equals 15. So this time, this 3 times 0, this entire piece will go to 0. And negative 5y plus 0 is just going to be negative 5y. From there, it's a pretty easy solve. We'll divide both sides by negative 5 to get that y equals a negative 3. So our y-intercept is 0, because that was our x value, comma, negative 3. So we'll plot 0, negative 3. And then once we have those two lines, that is enough in order to graph. Or I'm sorry, those 2 points, we'll connect them with a line. Sorry, I'm trying to get my ruler quite right. There it is. And so our graph should look something like that. Okay. So looking at number 6, we have an x equals equation. So when we have an x equals equation, there's actually an undefined slope here. Okay. And that's because y equals equations have a slope that's actually a number. Now that number could be 0, right? If we had, say, y equals 4, this graph, this y equals 4, has a slope of 0 and an intercept of 4. But whenever we have x equals just some number, which is what we have in this case, that is an undefined slope. And with that being an undefined slope, we kind of have to look at our graph to see if we have an intercept. Because we would only really have an intercept if it was x equals 0. Because if we plotted x equals 4, that is a vertical line through the value of 4. So this is the graph of x equals 4. Okay, so we should see that it's not intersecting that y-axis. So there actually is not a y-intercept. This is one of the few cases where there is not a y-intercept. Typically, if you have an x equals, there's probably not going to be a y-intercept. There can be, but it's either the graph x equals 0, which has an infinite number of y-intercepts, or it doesn't have a y-intercept. So that's kind of the difference there. So again, x equals some number is a vertical line. We also need to remember that if we had y equals a number, that's going to be a horizontal line. And we'll get to that a little bit later. Okay, so number 7, again, this is in that y equals mx plus b form. So our slope is going to be the coefficient in front of x, which is 3. And our intercept is this number added on the end, which is -2. So again, we're going to write that as a point. So it's 0, -2. And we'll start by plotting that point, 0, -2. So then my slope is 3, which is the same thing as saying 3 over 1. So both of those are positive. So we're going to go in the positive direction for both of those. So that means we're going to go up 3 and to the right 1. Okay. So we can go from this point up 1, 2, 3 and to the right 1. Again, we can also flip both of those arrows and go down 3 and to the left 1. So down 1, 2, 3 and to the left 1. And we can continue our graph in both directions. I'm only going to require that you plot 2 points in order to get these graphs to work, but I just want to show you how you could get more if you needed to, especially as we get into the solving systems by graphing. And so that would be our line. So hopefully those weren't too bad. We're just solving equations. Hopefully we know how to do that. So let's move on to some graphing things. So this says write an equation of the line using the given information. Your answers should be in point slope form. So hopefully we remember that point slope form is y equals m times x minus x1 plus y1. Okay, so this is being really specific about writing your answers in point slope form. So looking at this first one, we may be really tempted to write it in slope intercept form. And so slope intercept form is that y equals mx plus b. But again, this is really specific and it says write it in point slope form. So we can't use that. So we're going to use this instead. So we already know what we're going to substitute in for m, but we don't have a b in this equation. However, we should hopefully remember that our b is our y-intercept, which can always be written as the point 0, comma, and then whatever the y-intercept is, which in this case is -2. The y-intercept always has an x value of 0. So now we have the slope and a point. We can call this x1, y1, and then we can plug this information into the equation. So we would say y equals 1/3, which I plugged in for m, x minus x1, which is 0, plus y1, which is -2. So we're not going to write plus and -2. We're just going to write -2. Because hopefully we know that plus a -2 is the same thing as just -2. And so this would be our answer. Now you may be saying, well, this is just the same thing as 1/3 x minus 2, which you're exactly right. And that would be slope-intercept form. But because it wanted it in point slope, we don't need to distribute out, simplify, or anything like that. We can just leave our answer as is. Okay, now this one's a little bit tricky. So you may be looking at this and you may go, oh my gosh, it's a horizontal line. Okay, so horizontal lines have the equation of y equals, and then whatever the number is, -2. Okay, but again, the directions here were really specific and they said point slope form. Depending on who your teacher is, they may or may not take this. I would probably take this, but depending on who your teacher is, you need to make sure you can write it both ways, because if you want to write it in point slope form, that's important. So we should hopefully know that the slope of a horizontal line is 0, right? It's a 0 slope. The slope of a vertical line is undefined, but the slope of a horizontal line is 0. Okay, so that is our slope, and we're also going to need a point. And you can pick any point on this line. I'm just going to pick this one right here. And hopefully we know that that point is 0, -2. Okay, so I have a slope and a point on that line, so I can use my point slope. So again, going back to the y equals m times x minus x1 plus y1, where in this case our m is 0. We'll keep x the same, and this would be x1, y1. So minus 0, and then y1 is a -2. Again, if you distribute that 0 out and simplified, you would get this answer. But it kind of just depends on what the directions say, because this would be that answer in point slope form. I would personally take either of those, but again, make sure if you're using this for a different class other than Mrs. Hubbard's class, you're being very specific with what your teacher wants. Okay, so this one's nice. We don't have to hunt for a point. We're already given a point. We already know that this should be x1, y1. Okay, and we already know what our slope is, so we can go ahead and plug it into that equation. This is a really, really great equation to know. Very important for us to know this equation. So we'll substitute in -2/7 for n. Keep x the same. We'll substitute in a +5, but remember it's subtraction, so it'll be -5 for that x1. And we'll substitute in a -4 for that y1. Again, remember it would be plus a -4, but we don't want to do double signs like that, so we're just going to write it as -4. And this would be our answer. Okay, I'm going to show you a couple of different ways to do 12. I think that 12 is a little difficult to graph, so you kind of have two options here. You can sketch a really rough graph, or you can use the slope formula. So I'm going to start by using the slope formula just to show you that we're going to get the same thing. So the slope formula says y2 minus y1 over x2 minus x1, okay? Where this is x1, y1, and x2, y2. And so all we're going to do here is plug in these values. So y2 is 23, and I'm subtracting y1, which is 8. I'm putting that over x2, which is a -2, and I'm subtracting x1, which is a +3. So 23 minus 8 will give us 15. We'll simplify that numerator first, and then -2 minus 3 will give us a -5. 15 divided by -5 is a -3. Okay, so that will be our slope. Now, let's say if I wanted to do this graphically, okay, we can sketch a really rough graph. So one point that we have is 3, 8. Okay, so 3, and then I'm going to do these. These will be in increments of 1, 2, 3, 4, -1, -2, -3. And then my vertical will be in increments of 4, I guess. So like 4, 8,
12, 16, 20, and this will be 24. Okay, so one point that we have here is 3, 8. So 3, 8 is right here, and that's this first point that I'm graphing. The other point we have is negative 2, 23. So negative 2, 23 is happening right about here. Okay, so that's this point. So we can also calculate this as the change in y over the change in x. So we say, what is the vertical difference between these 2 points? Okay, well, if this is at the value of negative 223, and this is at the value of 3, 8, vertically, they have a difference of 15. Okay, so vertically, they have a difference of 15. And then we say, okay, horizontally, what is their difference there? So horizontally between this point and this point, what is their difference? Well, again, one is negative 2 and one is a positive 3. So horizontally, they have a difference of 5. And then we got to check whether it's a positive or a negative slope. Well, if I connected these dots, it's decreasing. So that means this is going to be a negative slope. So my slope is a negative 3. So either way you do it, whether you use the equation or graphically, you're going to get that your slope is a negative 3. So m equals negative 3 is what we got from that. Then we're not done yet, okay? Just because we found the slope doesn't mean we're done, because this asks you to write an equation in point slope form. So we have to go back to the y equals m times x minus x1 plus y1, okay? It does not matter which point you pick. Either point will give you the same answer. Okay, so we're going to use that slope that we found, which was negative 3. And I'm just going to use the first point. So it'd be x minus x1, which is 3, plus y1, which is 8. Another viable answer for this, if you decided to use the second point, would be that y equals negative 3x plus 2, right? Because you'd have a double negative there, plus 23. I typically try to pick points that are positive, but either of these answers are correct, and both would be accepted. So the trickiest part about that is probably finding the slope, but just make sure you're using a method that works for you. Okay, so the next one says write an equation of a line parallel that goes through this point. So in order to find something that's parallel, that means whatever our original equation has, we're going to use the same slope. Okay, same slope. But we don't know what the slope is from looking at this, right? We don't have y solved for, so it's not really easy to see what exactly the original slope is. Okay, a lot of people want to jump and say, oh, it's 2, but it's not 2 because this isn't in slope-intercept form or point slope form. So we don't really know what the slope is because this is in what's called standard form. So we're going to convert it into slope-intercept or point slope, one of the two, so that we can identify our slope. Because this is in standard form. And do you see the word slope anywhere in that sentence? No, standard form doesn't immediately identify the slope. So the way we convert it into slope-intercept form is we want to solve for y. So essentially we're kind of working in a backwards PEMDAS, and we're solving for y. We've solved for x before, so we should hopefully know how to do this. So we want to move any other variables. We want to get them to the opposite side. So I'm going to do that by subtracting 2x from both sides. So I'll get negative 5y equals a negative 2x, right, because it's going to cancel on the left side, minus 20. Okay, so we got a little closer. We moved x to the opposite side. And now we need to solve for y. So we still have that negative 5 attached to the y, and it's attached by multiplication, so we get rid of it by division. And when we divide one piece of our equation, we have to divide every single piece by that number. So the negative 5's on the left will cancel out, leaving us with y. Negative 2 divided by a negative 5, those when you divide a negative by a negative, you get a positive number. So that's going to be 2/5 x. And negative 20 divided by negative 5 will be a positive 4. Now this is in y equals mx plus b form. So we can pick out our slope, which in this case is 2/3. Right? That's where the m is. So because we want something parallel, we want our new line to have that same slope. So our new line is going to have a slope of 2/5. And it says it's going through the point 2, -3, which again is x1, y1. So once we identify that, we're going to go back to that equation we've been using this entire time, which is y equals m times x minus x1 plus y1. And we're going to plug it all in. So we'll say y equals that parallel slope of 2/5 times x minus x1, which is 2, plus y1, which is a -3. So plus a negative would just be a -3. And this is our final answer. Okay. Now the next one asks is easier and harder all in the same problem. Because the next one is asking us to find a line that is perpendicular. So perpendicular does not have the same slope. Perpendicular has what we call the opposite reciprocal slope. So I abbreviate that as opposite recip. Okay. Basically what that means is we need to flip the sign, but we also need to flip the fraction. Because opposite means opposite sign and reciprocal means the reciprocal fraction. So flipping it. So looking at this problem, we already have y solved for. So this is already in y equals mx plus b form. Okay, so our original slope is 2. However, and if we were working with parallel, we would use 2 as our slope. But we want something perpendicular. So that means we need to take that slope and we need to get the opposite reciprocal. So we're going to take this 2. So if that 2 is originally positive, our new slope is going to be negative. And if that original slope is 2/1, then we'd have to flip that to get the reciprocal. So it'd be a -1/2. Okay, so again, we flipped the sign, and 2/1, we'd have to flip that fraction to be 1/2. So this would be our new slope. And again, we're given a point, so that's great. And we can go back to that same equation we've been using this entire time. So we'll say y equals the new slope we found, which is a -1/2 times x minus x1, which is 5, plus y1, which again would be plus a negative. So we just write it as -8. And so this is our answer.